Hi, we're going to look at some linear equations, and we would like to make a representation on a graph of the equation by drawing an appropriate line. And the strategy we're going to use is we're going to record and plot at least 5 ordered pairs. In the first example that I have for you, we're going to look at the equation x plus 2y equals 8, and we want to write down some ordered pairs, x comma y, such that when you plug in x and you plug in y, this equal sign is true. And we're going to do 5 of those. So we're going to make an XY chart with our results. And as I peek ahead, and I see that my graph paper has been numbered from, well, this is a -6 to +6, both axes. I'm going to have some room for some negative input and some positive input to find the output y. So I think I might start with letting x equal -2. Alright, I'm going to plug in x equals -2 into the equation x plus 2y equals 8. And now I'm going to isolate y to solve for y. And we know how to do that. We're going to add 2 to both sides. And we're going to divide both sides by +2. And to make this original equal sign true, when x is -2, y is 5. And later we will plot the ordered pair -2, 5. Okay, let's try another ordered pair. This one shouldn't be hard. Let's let x be 0. The same equation, x plus 2y equals 8. We substitute 0 for x. We record plus 2y equals 8. And on the left-hand side, we just have 2y when we simplify. We write down the equivalent equation step by step, both sides, and now we divide both sides by 2, and the result is 4. Y is 4. And in a moment I will graph the y-intercept 0, 4. If you want to try a few more on your own, you could pause the video and maybe try plugging in these even values of x. Okay. And feel free to use some scratch paper. Pause now if you choose to. Okay. If x is 2, and we add 2y and set that equal to 8 for our third example, we're going to subtract 2 from both sides, then divide both sides by 2, and we see that y would be 3. And in a moment we'll record the ordered pair 2, 3. If we substitute x equals 4, we'll end up having to subtract 4 from both sides. It'll say 2y equals 4, which is equivalent to y equals 2. You can check that with some scratch paper. And if we plug in x equals 6 and start again, we'd have to subtract 6 from both sides. And 2y equals 2 implies that y equals 1. So let's move to graphing these ordered pairs. Okay, again, if you look back at your scratch paper, we had the ordered pair -2, 5, the y-intercept 0, 4, the ordered pair 2, 3, 4, 2, and the ordered pair 6, 1. This should have a graph of a line because x is to the first power and y is to the first power. The graph should be linear. So we focus at the origin of the graph, and then we want to move 2 to the left and 5 upwards. The x value you move left and right, so we're going to move left 2 and up 5 and record the ordered pair -2, 5. Then we'll start over, focus the origin. We move neither left or right, but then we move up 4 for the y-intercept 0, 4. The third ordered pair, we're going to move right 2 and up 3. Next we'll move right 4 and up 2. The line's looking pretty good. And finally we'll move right 6 up 1. And linear equations don't have to just have integer input. X and y can also be rational numbers or irrational numbers, and we know that the graph is a continuous straight line, so we can connect those dots. And in later exercises, you might look to see if you can calculate the slope of this line. We see that this line is decreasing, and so its slope should be negative. You might check that later. Okay. Well, you might want to pause the video again and look at this second example. Down here at the bottom of the page, I have the linear equation 3x minus 2y equals 15. And I'm going to have the same graph paper. So I can choose values of x that are similar to the previous example. But maybe to be different, we might pick, some odd numbers, maybe 5, 3, 1. We'll graph those 3 ordered pairs, and if we need some others to finish out the pattern, that's fine. Okay, so the example 2, we're going to try letting x equal 5. So in our scratch paper, we need to write down 3 times 5 minus 2y equals 15. And as before, we need to solve this equation for y. Alright, so why don't we simplify this product? And we see to isolate y, we need to first subtract 15 from both sides. And we can see what's going to happen. Even when we divide both sides by 2, y is going to be 0. So we have an x-intercept there. Anytime y is 0, that ordered pair will be on the x-axis, the horizontal axis, and we have an x-intercept. Okay, let's start over again, same equation. Plug in 3 for x, simplify, try to isolate the y term, which means the final step we need to divide by -2. And we have the ordered pair 3, -3 that satisfies the given equation. Okay. If we substitute 1 for x, we're going to get 3. Subtracting 3 from both sides, we'll get a positive 12 on the other side. And you can double check me, but 1, -6 should satisfy that equation. We didn't show this before, but if you want to check an ordered pair, for example, check that this is a solution to this linear equation, just substitute the value 1 for x, substitute -6 for y, and simplify the left-hand side. Excuse me. When we simplify the left-hand side, we get 15, and we notice that that matches the right-hand side. So for completeness, let's graph those 3 ordered pairs. If you look back, we had the x-intercept 5, 0, the ordered pair 3, -3, and the ordered pair 3, -6. Okay, actually this is a little bit different graph paper. It looks like I've put some more negative y values than x. That's interesting. It's looking ahead. Do you see where the ordered pair 5, 0 goes? We start at the origin, move right 5 units, and then move neither up or down, and we have our x-intercept at 5, 0. Starting over, we move 3 to the right, and then 3 downward. And finally we move 1 to the right and 6 downward. And we have an increasing line, a line whose slope would be positive. Okay. Thank you for joining me as we've graphed linear equations by making a table.